Intermediate Algebra for Statistics, Sections 4.1 and 4.2, the Distributive Law and Simplifying Expressions. Lesson objective: simplify expressions using the distributive property and combining like terms. Lesson objective number 1. A term is a constant, variable, or a product of a constant and variable, and one or more variables raised to powers. Variable terms are terms that contain variables. Constant terms are terms that do not contain variables. These are terms that stay the same. Here's the distributive law, or sometimes called the distributive property. This is where we have a quantity A times a sum, in this case B plus C. So it's A times B plus A times C. So in words, we find A times the quantity B plus C. Distribute A to both B and C. Example 1. Find the product. Number 1, we have 3 times the quantity x plus 5. So we have to distribute the 3 over the x and over the 5. So this is 3 times x, 3x plus 3 times 5, which is 3x plus 15. Number 2, distribute the 5. 5 times 2x is 10x plus 5 times 4y, which is 20y. Example 2, find the product of 3 times the quantity 2t minus 5w plus 4. This time we have 3 terms, so we still distribute the 3 times each of the 3 terms. So we have 3 times 2t minus 3 times 5w plus 3 times 4. This becomes 6t minus 15w plus 12. Example 3. Evaluate both the expressions 3 times the quantity x plus 5 and 3x plus 15 for the given values of x. Number 1, x equals 2. Number 2, x equals 4. And number 3, x equals 0, 1, 2, 3, 4, 5, 6. Now for number 3, we'll use the graphing calculator and the table feature to save some time. So number 1, if we substitute 2 into this expression, we get 3 times quantity 2 plus 5. We can combine these two and we get 7. 3 times 7 is 21. Other expression, 3 times 2 plus 15, order of operations says we multiply. We get 6 before we add, we get 15. The answer again is 21. These are the same. For number 2, x is now 4. We do the same procedure. We do parentheses first, then we multiply. We get 27. For the second expression, we get 3 times 4. We multiply, then we add. And again, we get the same value. Now this suggests that these two are equivalent. So we have our graphing calculator. What we want to do is we want to put the two expressions in what's called the y equals, which is right here. So when you press the y equals, you get this screen. Now if you have a stat plot turned on, you can turn it off by using your arrow key and hitting enter. In this case, my stat plot is off, so I'm okay. So we type in the first expression, 3 parentheses x plus 5, close parenthesis. Then for the next expression, we hit enter. It goes to y2, and we want to type in 3x plus 15. We want to use the table feature and compare these two. The table feature can be found by using the second key and then the graph key, and we notice that table is written in blue because when we hit our second key it's blue. So this will change it to table. But before we do that, we need to set the table to what we want. We want the values of 1 through 6. We go to second window, which is table set. So second window. Okay, this is telling me to start at 0. That's what I want. And it's telling me this means how much to count by. And since we want the values 1, 2, 3, 4, 5, 6, we want to count by 1. So now we can hit second in graph, which is table, and we see here our x values. We want 1, 2, 3, 4, 5, 6, and we see that the y1 and y2 all have the same values. So these two expressions are equivalent. So the results of evaluating the two expressions are equal. Example 4. Simplify 4x times the quantity 2t minus 3 minus 7. First we have to apply the distributive property. 4 times 2t is 8t minus 4 times 3, which is 12. We can combine these. Minus 12 minus 7 produces minus 19. Number 2, it would be a mistake to take 5 minus 6 because the 6 is multiplying and we multiply before we subtract. We can think of this as negative 6 times x and negative 6 times minus 2, which produces negative 6x plus 12. Now we can combine the positive 5 and the positive 12, which gives us a result of negative 6x plus 17. Negative 1 times a is equivalent to negative a. So in words, negative 1 times a number is equal to the opposite of that number. Let's do an example using this idea. Example 5. Simplify 7 minus the quantity x plus 9. So the first thing that we want to think about is this minus as a negative 1. So we take negative 1 times x and negative 1 times 9, which gives us 7 minus x minus 9. We can combine these two, and we're left with minus x minus 2. Example 6. Simplify the negative of the quantity x minus 4y plus 7. Again, we can think of this minus as a negative 1. Distribute negative 1 over all three terms. Gives us negative x plus 4y minus 7. And if we can see here, basically for each term the sign changed. Now let's do an example involving numerical expressions. Imagine if we didn't have a calculator and we're asked to compute what is 7 times 102. Well, by using the distributive property, we could rewrite this as 7 times 100 plus 2. And then by using the distributive property, we would take 7 times 100, which is 700, plus 7 times 2, which is 14. So the answer is 714. Now if we're asked to do this problem, 6 times 97, well, that's equivalent to saying 6 times 100 minus 3, because 97 is the same thing as 100 minus 3. Then we distribute the 6 over 100, which is 600, minus 6 times 3, which is 18. So this is equivalent to 582. Combining like terms. To combine like terms, you add the coefficients, which that's the numbers in front of the variables, coefficients, of the terms, and keep the same variable factors. We simplify an expression by removing parentheses and combining like terms. Example 7. We want to simplify each of these expressions. So for number 1, if we were to group the x's together, then the y's together, we have 2x minus 6x plus 5y plus 3y plus 2 plus 7. And combining the coefficients, get a negative 4x plus 8y plus 9. Number 2, we have to distribute first. Negative 2 times x, negative 2 times plus 5y, negative 3 times 2x, and negative 3 times a negative 4y gives us negative 2x minus 10y minus 6x plus 12y. Combining the x's, we get negative 8x. Combining the y's, we get a positive 2y. Number 3, again we have to do the distributive property first. That gives us 4x minus 8 minus x minus 3. We get positive 3x minus 11. This is our last example. Example 8. Considering the following incorrect work. We have 5x plus 6 plus 3 times the quantity x plus 4. This becomes 5x plus 6 plus 3x plus 4. Combining like terms, we get 8x plus 10. Now there's a mistake here. We want to verify this mistake by using the graphing calculator, and then we want to pinpoint where the error was made. Putting this in our graphing calculator in y1, 5x plus 6 plus 3 times x plus 4, and y2, 8x plus 10. Using our table feature, we see these values are not equivalent, so an error has been made. So since the calculator illustrates that the two expressions are not equivalent, a mistake has been made, and the actual mistake is, instead of plus 4, it should be plus 12. Person forgot to distribute the 3 to the 4, which is a common mistake. Here's the readings and suggested problems. Thanks for watching.